Moment, madam. Just a moment.
Okay, okay.
Start, madam.
Good morning to one and all. Myself Swapna, JL in chemistry from Vangara. Yesterday, what we discussed, my dear students, those are Cosell-Lewis approach to chemical bonding, octet rule and its limitations, Lewis dot structures, and types of chemical bonds. Okay. Now we will discuss shortly types of chemical bonds. The comparison of ionic, covalent, and coordinate bonds. How these are formed. Okay, ionic bond. It is a strong electrostatic force of attraction that holds oppositely charged ions together is called ionic bond. It is formed by the transfer of one or more electrons from one atom to another atom. Example, formation of sodium chloride and formation of magnesium chloride also. Then covalent bond. It is formed by the mutual sharing of electron pair between two atoms in a molecule. And coordinate bond. It is also same form in the formation as covalent bond. That means it is also formed by the mutual sharing of electron pair between two atoms in a molecule. But small difference between these two covalent and coordinate bonds. That is in the covalent bond, the atoms which are participating in the bond formation contributes the electrons equally for sharing. But in a coordinate bond, the electron pair contributed the only one of the bonded atoms. That is the difference between these covalent and coordinate bond. Otherwise, the formation is same. Okay. The covalent bond, example, the formation of H2 and O2, N2 and CH molecule, etc. Example for the coordinate bond, formation of ammonium ion. I hope you understood the difference between the ionic, covalent, and coordinate bonds. Then, now comparison in their properties. First of all, physical state. In the ionic bonds, the ionic compounds are crystalline solids because of the strong electrostatic force of attractions among them. That is the reason these are crystalline solids. Then covalent compounds, those are soft solids. Example, sulfur, phosphorus, and iodines, and liquids and gases. Then in this, the weak force of attractions are present when compared to ionic bond. In coordinate bond, those compounds are solids as well as liquids and gases also. Then difference in their melting and boiling points. The ionic compounds have high melting points because of the forces between oppositely charged ions. But in covalent compounds has low melting and boiling points because of the molecules are held together by weak force of attractions when compared to ionic compounds. In coordinate compounds, those are neither very high nor very low. That means these melting boiling points are between these ionic and covalent compounds. Next property is solubility. These ionic compounds are soluble in polar solvents like water, H2O, and aqueous ammonia. But covalent compounds, non-polar solvents, it dissolves in non-polar solvents like benzene, chloroforms. Coordinate bonds dissolves more in non-polar solvents than polar solvents. Next property is conductivity. They conduct electricity in fused and in aqueous state. But covalent compounds are bad conductor of electricity because of there is no free of electrons and ions in these covalent compounds. That is the reason those bad conductors in coordinate compounds do not conduct electricity since they do ionize. These are comparison of properties of ionic, covalent and coordinate compounds. Next goes to hydrogen bond. It is the weak electrostatic force of attractions between a partially positively charged hydrogen atom and highly electronegative atoms of the same or different molecules. Now, what are the high electronegative atoms of elements in our total periodic table? I hope do you know, students? Those are fluorine, oxygen, nitrogen and chlorine. Okay. Then here, what I told you, it is the weak electrostatic force of attraction between a partially positively charged hydrogen atom and highly electronegative atom of the same or different molecules. Yes. Then how these gets the partial positive charge and partial negative charges? This charge is possible in only dissimilar atoms. Example, HCl. In HCl molecule, the covalent bond in which the electrons are shared unequally between these two atoms. Thus, they acquire partial charges. Then now, types of hydrogen bonds. The hydrogen bonds are two types. Those are intermolecular hydrogen bonds and intramolecular hydrogen bonds. Generally, the hydrogen bond is denoted with the dotted lines. Okay. Now, let us discuss intermolecular hydrogen bond. It is formed between the two different polar molecules. That means it is formed between two different molecules of the same substance or different substance is known as intermolecular hydrogen bond. What is the intermolecular hydrogen bond? The bond formed between two different molecules of same substance or of different substance is known as intermolecular hydrogen bond. This is the examples to the intermolecular hydrogen bond of same substances of different molecules. Okay, this is the hydrogen bond. The bond formed between these water molecules. These are different molecules but same substances. Thus, the bond formed between these two water molecules. The hydrogen bond between ammonia and ammonia molecules. Same as well, here also the hydrogen bond formed between two different ammonia molecules of same substances. Here, if you observe, the hydrogen bond formed between the high electronegativity of the nitrogen atom and the partial positively charged hydrogen atom. So that it is represented the dotted lines. This last represents the hydrogen bond. Next example, the hydrogen bond formed between the water molecules and ammonia. These are two different molecules and different substances. Okay, the hydrogen bond formed between these two are different molecules and then different substances. In this one also here, the hydrogen bond formed between partial negative charge, that is high electronegatively charged nitrogen atom, and to the partial positively charged hydrogen atom. So in this the hydrogen bond is represented with the dotted lines. These are belongs to intermolecular hydrogen bond. Next goes to intramolecular hydrogen bond. It is formed with a molecule. That means it is formed between a hydrogen atom of molecule and highly electronegative atom of the same molecule. So that is called intramolecular hydrogen bond. Example, orthonitrophenol. It is the benzene ring. Okay, this is the benzene. If OH present on benzene ring is called phenol. Okay, if OH group is present on this benzene ring is called phenol. Okay, if it, let us use the numbering, first number to the here and second number here, third number here, fourth number here. The first position and second position is called ortho positions. The first position and third positions are called meta position. First position and fourth positions are called para position. Is orthonitrophenol, the nitrogen NO2 group. The NO2 group is present on the which position, Nana? Ortho position. Because of this is the first position and this is the second position. Then first and two is called ortho positions. So here in this the NO2 group present on the second position. That is the reason it is called ortho nitrophenol. Okay, the OH group present on the benzene ring is called phenol, and also the NO2 group present on the ortho position of this benzene ring. That is the reason it is called the orthonitrophenol. In this, the hydrogen bond formed between the partially positively charged hydrogen atom and highly electronegativity atom of the oxygen. So thus, here the hydrogen bond formed within a molecule, so that it is best examples to the intramolecular hydrogen bonding. Next goes to another example is salicylaldehyde. Okay, next it is the salicylaldehyde. If the CHO group present on the benzene ring, if CHO group is present on this benzene ring is called the benzaldehyde. Okay, if the OH group is present on this ortho position, then that is called the orthohydroxy benzaldehyde. It is also called salicylaldehyde. Okay, students, here if the CHO group present on the benzene ring, then that is called benzaldehyde. Okay, then if the OH group is present on the ortho position, then it is called the orthohydroxy benzaldehyde. It is also called salicylaldehyde. Here the hydrogen bond formed between the high electronegativity of the oxygen atom and partially positively charged hydrogen atom. Thus, here the hydrogen bond formed within a molecule. This is called intramolecular hydrogen bond. Next goes to Poisson's rules. Generally, these rules are useful to predict the nature of the these rules are useful to predict the nature of bond formed between atoms. Nature of bond means here actually the 100% of ionic bond and then 100% of covalent bond is not possible. That means the covalent compounds has some of the ionic nature and ionic compounds have the covalent nature. So these rules are predict the nature of the bond formed between two atoms in a molecule. Those are size of the cation. If the size of the cation increases, then ionic nature of the bond also increases. In a group from the top to bottom, if you observe these examples, that is the beryllium chloride, magnesium chloride, calcium chloride, strontium chloride, and barium chloride, in those all are get the +2 charges. Here beryllium gets +2 charge, magnesium gets +2 charge, in this calcium gets +2 charge, and strontium gets +2 charge, and barium also get the +2 charge. So that from the in a group from the top to bottom here, beryllium to barium, the cation size is increasing. Whenever the cation size increases, what happens? The ionic nature of the bond also increases. Here, whenever the ionic nature increases, then covalent nature is decreases. It is totally opposite. The ionic nature is totally opposite to the covalent nature. Okay. Then in a period from the sodium to silicon, here the sodium has 1 positive charge, then magnesium has 2 positive charge, aluminum has 3 positive charge. Here silicon has 4 positive charges. Already I told you in previous class, that is the, if the positive charge increases, what happen, Anna? If the positive charge increases, the size is automatically decreased. Yes, yes. So here from the here sodium ion to silicon ion, the charge, positive charges are increasing. When the positive charges are increasing, the size is automatically decreases. Okay, okay. Whenever the size is automatically decreases, then what happened to ionic nature? The ionic nature is also decreases. Whenever the ionic nature is decreases, what I told you, the ionic nature is opposite to the covalent nature. So that whenever the ionic nature decreases, then covalent nature is automatically increases. Next goes to size of ion. If anion size increases, the covalent character is increases. That means the ionic size is directly proportional to the covalent character. Then in case of halves of calcium, here calcium fluoride, calcium chloride, and calcium bromide, and calcium iodines. These fluoride, chloride, bromine, iodines all are belongs to seventh group elements. Those are all halogens. We know that, yes, yes. In this, the if these divided calcium and fluorine, then here get fluoride ion. Here are chloride ions, and these are also bromide ions, and so we get here iodide ions. Whenever the here, what when size of anion increases, because of that in a group from the top to bottom, what happen, the sizes are increases. Already you learned in the second lesson. Yes, yes. From fluoride to calcium means then fluoride ion to iodide ion, sizes are increasing because of these are belongs to seventh group elements. So that here the sizes of anion increasing. What happens? Size of anion increases, here ionic character is decreases. Whenever the size of anion increases, then covalent character is increases because the anion size is direct proportional to the covalent character. Whenever the size of ion increases, then covalent character is merely increases. Next goes to charge on the ion. Charge on ion is directly proportional to the covalent character and inversely proportional to the ionic character. Here, sodium chloride, magnesium chloride, and sodium chloride, magnesium chloride, and aluminum chloride, and silicon chloride. In this, the charge on the can increases because these goes if they are undergoes to ionization forms the sodium chloride undergoes to forms the sodium plus ion. Here the MgCl2 undergoes to ionization forms the Mg2 ion. In this, the in aluminum chloride, in this the aluminum gets the positive charge. In this, the silicon also gets the positive charges. Here sodium gets 1 positive charge, magnesium gets 2 positive charges, and same as well here aluminum gets plus 3 charge and silicon gets plus 4 charge. Here the charge on the cation increases, the ionic character also decreases. Whenever the ionic character decreases, then covalent character is increases. Totally here the ionic character is opposite to the covalent character. You remember that point. Next, electronic configuration of cation. Already we discussed about the electronic configurations in the factors favorable conditions for the formation of cation. I hope you remember. Compounds with cation with inert gas configuration are more ionic. Yes, yes. The pseudo inert gas configuration are more covalent in nature. Already we discussed this point. In sodium chloride, the sodium plus has inert gas configuration. If you write this electronic configuration, then you will understood easily. In the CuCl, then Cu plus has pseudo inert gas configuration. Then here pseudo inert gas configuration of the compounds are more covalent in nature. Thus here CuCl is in more covalent in nature. These are Poisson rules. Next goes to, let us discuss the VBT. What is a VBT? Valence bond theory. Already you learned this one in your previous class. That means in 10th class. It was proposed by the Hitler at London. It was modified by Pauling and Slater. According to this theory, covalent bond formed by the overlapping of atomic orbitals. Okay, a covalent bond is formed by overlapping of valence atomic orbital of an atom containing a single electron overlap with an atomic orbital of another atom with an electron of opposite spin. Okay, the covalent bond is formed by overlapping of valence atomic orbital of an atom containing a single electron overlap with an atomic orbital of another atom with an electron of opposite spin. The orbitals are involved in overlapping to form chemical bond is called localized orbitals. You remember this, Nana? The orbitals are involved in overlapping to form chemical bond are called localized orbitals. Overlapping of orbitals causes delocalization of electrons, which in turn lower the energy and increase the stability. Resulting the bond acquires a pair of electrons with opposite spin to stability. The strength of the bond depends on the extent of overlapping. Greater the overlapping orbitals leads to strong the bond. The order of overlap of p orbitals is SS overlap is greater than the S and p orbitals, and S overlap is greater than the and p orbital. The direction of overlapping of orbitals will be the direction of bond formed. The orbitals can overlap to this. Those are axial overlapping and lateral overlapping. Axial overlapping. By the axial overlapping, the sigma bond is formed. Yes. Here, atomic orbitals overlap along the internuclear axis, involve end-to-end or head-on overlapping. This is the axial overlapping types. Those are SS overlapping and SP overlapping and PP overlap. Here, SS overlapping. This SS overlapping to half-filled s orbital of the atoms approach to form sigma bond. That is SS sigma bond. Example, formation of H2 molecule. Hydrogen has one electron in its orbitals, that electronic configuration is 1s1. These orbitals having unpaired electron overlaps axially with the 1s orbital of another hydrogen atom to form a sigma bond. Thus, H2 molecule is formed. Okay, in this 1s orbital of the unpaired electron of 1s orbital of hydrogen atom overlap axially with the 1s orbit of the another hydrogen atom to form sigma bond, thus forms the H2 molecule. Next goes to sp overlapping. Involves overlapping of half s orbital of the one atom, the half filled p orbital of another atom. The bond formed is called sp overlapping. Example, formation of HCl molecule. Electron configuration of hydrogen is 1s1. We know that its atomic number is 1, so its electron configuration is 1s1. Then about chlorine, its atomic number is 17, so its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. Then it has one unpaired electron in 3pz orbital. So that here hydrogen of 1s orbital and chlorine of 3pz orbitals overlap with each other axially to form a single bond, thus formed HCl molecule. Yes. In this 1s orbitals of the hydrogen atom and 3pz orbital of the chlorine atom overlap with each other axially to form a HCl molecule. The sigma bond is formed. PP overlapping. The involving overlapping of far field of p orbitals of the two atoms. The bond so formed is called pp bond. Example, chlorine molecule. In this, the chlorine atomic number is 17. So its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. In this, it has one paired electrons in 3pz orbitals. Okay. So that here the 3p orbitals of containing the unpaired electrons of two chlorine atoms overlap each other axially to form a sigma bond. From the Cl2 molecule. Then sidewise overlapping. By the sidewise overlapping bond is formed. Here electrons orient above the and below the internuclear axis. Example, the formation of O2 molecule. Here the oxygen electron configuration. Its atomic number. Do you know atomic number? Yes. Its electronic configuration is 1s2, 2s2 and p4. It has two paired electrons in 2py and 2pz orbitals. So that here two paired orbit of each oxygen atom overlap to each other axially to form a sigma bond. But here two py orbitals of the two oxygen atoms perpendicular to the overlap the perpendicular axis and laterally overlap to form a pi bond. Thus, O2 molecule is formed. Then now difference between the sigma and pi bonds. Okay. Sigma bond. It is a strong bond. Then pi bond, it is a weak bond. It can exist independently, but it exists along the bond. It allows the free rotation of bonded atoms. It restricts the free rotation of bonded atoms. Electron cloud of sigma bond is along the internuclear axis of the bonded atoms. In this, the electron cloud of the bond lies O and the axis. All orbitals are S and D can form the sigma bonds. Here, except S orbital. S orbital not forms the pi bond. So, remaining all other orbitals can form pi bond. Both here, the pure and hybrid orbitals can form sigma bond. In this hybrid orbital cannot form pi bond. Bond is formed by the sigma bond is formed by the axial overlapping. This pi bond is formed by the lateral overlapping of orbitals. Now let us discuss VSEPR theory. VSEPR, that means valence shell electron pair repulsion theory. VSEPR is nothing but valence shell electron pair repulsion. It was proposed by the Sedgwick and Powell. Later, it was developed by the Nyholm and Tubbs. Process of theory. The shape of the molecule is determined by the arrangement and relations between all the electrons present in the valence shell of the central atom. Okay. What is explained theory? It is the shape of the molecule. This theory is determined the shape of the molecule determined by the arrangement and the repulsions between all of the electrons present in the valence shell of the central atom. That means it is depends upon total electron pairs present on the central atom. In a molecule, the central atom may contain two types of electron pairs. The valence shell. Those are one is lone pair and second one is bond pairs. Lone pairs means the electron pairs which do not participate in bond formation are called lone pairs. Lone pairs are nothing but the electron pairs which are not participate in bond formation is called lone pairs. These are belongs to atomic orbitals. Bond pairs. Bond pairs means the electron pairs which are participated in bond formation is called the bond pairs. These are belongs to localized orbitals. What I told you now, localized orbitals? Localized orbitals are nothing but bond pairs. Just now we discussed the orbitals which are involved in the bond formation are called the bond pairs. These are also belongs to localized orbitals, and these are also called molecular orbitals because of these bond pair belongs to the two bonded atoms. Here, the lone pair is attracted. If you observe the structure, the lone pair is attracted by the only one nucleus. It is, I taken example to better understand. Okay. Here, the lone pair is attracted by only one nucleus, while the bond pairs, these are bond pairs. These bond pairs are attracted by these two nucleuses. Okay, here the lone pair is attracted by the only one nucleus, but here the bond pair is attracted by the two nucleus. Here the atomic orbitals are nothing but lone pairs. Here, if you observe here, the lone pair occupies more space around the central atom than these bonded orbitals. That means molecular orbitals are bond pairs. Hence, repulsions between two lone pairs is greater than the two bond pairs. If the central atom contains only bond pairs, then shape of the molecule and bond angle will be according to the expected lines. If the central atom contains lone pairs along with bond pairs, then the shape of the molecule is deviated from the expected lines. This is due to the repulsion forces between various electron pairs. Okay, I hope you understood this point. If the central atom contains only bond pairs, then the shape of the molecule and bond angle will be according to the expected line. That means there is no change in their shape and bond angles. If the central atom contains the lone pairs along with bond pairs, the shape of the molecule is automatically deviated from the expected lines because of the repulsion forces in the various electron pairs. Next, the order of repulsions among the electron pairs will be the lone. This point is most important, so you remember this point. The lone pair repulsions is greater than the lone pair and bond pairs. Then lone pair bond pair repulsions are greater than the bond pairs. Yes. Here once again, lone pair repulsions are greater than the lone pair bond pairs. The lone pair bond pair repulsions greater than the bond pair and bond pair. The magnitude of repulsions between bond pairs of electrons depends on the electronegativity difference between central atom and the bonded atoms. If the electronegativity of the central atom, then the greater the electronegativity of the central atom, then the bond pair come near to the central atom. Whenever the bond comes near to the central atom, distance becomes maximum. Then it causes the greater repulsions. Then these repulsions lead to the decrease in bond angle. The repulsion forces between the bonds. Order of the repulsion forces. The triple bond repulsion is greater than the double bond. In the repulsions in double bonds is greater than the single bonds. Example in CH4. Okay, in the CH4, the central atom is carbon. Okay, in the CH4, the central atom is carbon. Its atomic number is 6. Once you will write, Nana, its atomic number is 6. Its electronic configuration is 1s2, 2s2 and 2p2. It is in ground state. It is undergoes to excited state. In its excited state, then 2s orbitals are jumped into 2pz orbitals. Then now in its excited state, it gets the 4 unpaired electrons. Whenever it get the 4 unpaired electrons, then these 4 unpaired electrons of the orbitals overlap with the 1s orbital of the electron of the 4 hydrogen atoms to form the CH4 molecule. Now its shape is tetrahedral. Its bond angle is 109.5 degrees. It does not have any lone pairs. That is the reason its shape is tetrahedral and bond angle is 109.5 degrees. If you observed in this ammonia molecule, the nitrogen is the central atom. Why will take the nitrogen as central atom? Because of it is the least electronegative element. That is the reason it is considered as the central atom. Then its atomic number is 7. You will write once again. Its electron configuration is 1s2, 2s2 and 2p3. Now it has 3 unpaired electrons in 3p orbitals and 1 lone pair in 2s orbitals. What happened? Here only the unpaired electrons are participated in bond formation. Thus, here px, py and 2pz orbital of the nitrogen overlap with the 1s orbital containing the electron of these 3 hydrogen atoms to form the ammonia molecule. But here its shape is pyramidal and its bond angle is 107.8 degrees. What happened here? Bond angle is reduced to 107.8 degrees. What is the reason? Here lone pair is present. Here the nitrogen has one lone pair. What happened? Just I told you the lone pair repulsion is greater than the lone pair bond pair, and the lone pair bond pair repulsion is greater than the bond pair and bond pair. Here nitrogen has lone pair, thus here this lone pair and this bond pair repulsions are greater than the bond pair. That's the reason that this bond angle is reduced from the 109 degrees 0.5 to 107.8 degrees. Next example is water molecule. Okay, in the central atom axis, then you write electronic configuration same as well. Okay, then automatically you get two lone pair of electrons. These two lone pair of electrons do not participate in bond formation. Then two electrons of the oxygen atom overlap the electron 1s orbital of the hydrogens to form the water molecule. Its shape is angular or V shape. Okay, and its bond angle is 14.5 degrees. What happened to this bond angle? Again here the bond angle is reduced to 14.5 degrees because here oxygen has two lone pairs. That is the reason here the lone pair repulsions are greater than the lone pair and bond pair. That is the bond angle is reduced to 104 degrees, 104.5 degrees. Then shape of the molecules having only bond pairs. Okay. The number of bond pairs. If the compound containing number of two bond pairs, then shape is linear. These are examples to the linear. Next goes to if the compounds containing the bond pairs, then the shape is triangular. These are examples. And if the bond pair are 4, then the shape is tetrahedral. Then these are examples to these shapes. Then next, if the atom containing the 5 bond pair, then the shape is trigonal bipyramidal. The examples are PCl5 and P5, etc. The total electron pairs are 6 bond pairs, then its shape is octahedral, and these are examples. Next, the total electron pairs or bond pairs those are 7. Then its shape is pentagonal bipyramidal, and this is the example to this pentagonal bipyramidal. Then shape of molecules in bond pairs as well as lone pairs. The bond pairs. Here the bond pairs 2, the lone pair 1. Total number of electron pairs are 3. Then here the shape is angular. Actually, if the atom contains the 2 bond pairs, then the shape is linear. But here the shape is angular because of it has one lone pair. So the lone pair bond pair repulsion is greater than the bond pair bond pair. That is the reason its shape is deviated to angular. Okay. Then if the bond pairs, the total pairs are 4. Of these total pairs, the bond pairs are 3. If the lone pair is 1 is present, then basic shape is tetrahedral. But here it has one lone pair. That is the reason the shape is deviated to pyramidal. Next goes to total number of electron pairs are 4. Of these electron pairs, if it contains the 2 bond pairs and 2 lone pairs, then its shape is actually, for the total number of bond pairs, the shape is tetrahedral. But it has 2 lone pairs. That is the reason the shape is changes to angular. Next goes to total number of, if total number of electron pairs are 5, then that shape is folded square. But here it has one lone pair along with the 4 bond pairs. So the shape is seesaw structure. The next goes to, if the total pairs is 5, then that shape is trigonal bipyramidal. But here it has 2 lone pairs along with the 3 bond pairs. Thus the shape is changes to T-shaped. Next, if the total number of pairs are 5, those are belongs to, if those are belongs to bond pairs, then the shape is trigonal bipyramidal. But it has 3 lone pairs along with 2 bond pairs, so that the shape is changes to linear. Here, if the total electron pairs 6 are bond pairs, then that shape is octahedral. But here it has one lone pair along with 5 bond pairs, then the shape is changes to square pyramidal. And if the total number of 6 electron pairs are bond pairs, then that shape is octahedral. But it has now 2 lone pairs along with 4 bond pairs. That is the reason the shape is changes to square planar. These are examples to related structures. These are structures. Here, this is the linear structure. Okay, here this is the linear structure. If the electron pairs are 2 pairs, those are belongs to bond pairs, then the shape is linear. If the atom having the total 3 electron pairs, those are if belongs to bond pairs, then the shape is trigonal planar. If the atom has 4 electron pairs, those are belongs to 4 bond pairs, then the shape is tetrahedral. Next, if the atom has 4 total electron pairs and it contains one lone pair along with 3 bond pairs, then that shape is changes to pyramidal. If the atom contains 4 electron pairs, of these 4 electron pairs, it has 2 lone pairs along with the bond pairs, the shape is changes to bent structure or V-shaped structure. If the atom has 5 electron pairs, if these 5 electron pairs are bond pairs, then the shape is trigonal bipyramidal. Next, if the atom has 6 electron pairs, these are belongs to bond pairs, then the shape is octahedral. Now,
Process system.
assignment. What is the hydrogen bond? And explain the different types of hydrogen bond with examples. And write the properties of the VSEPR theory and its applications. And also write the postulates of the VSEPR theory and its applications. So what we learn in this
Madam,
on the
madam,
sir
close the session, madam. Time.
close chestara
2 minutes, madam. You can close in 2 minutes.
only 2 minutes, okay sir. So what we learn today, we learn the difference between the ionic bond, covalent bond and coordinate bond, and also we discuss the hydrogen bond and types of hydrogen bonds, and we discuss the VBT, valence bond theory. Valence bond theory already you learned in 10th class. I hope you better understood. Okay, and next goes to we discuss the VSEPR theory. Then VSEPR means valence shell, electron pair, repulsion theory. And those postulates and examples are given. I hope you understood better. Thank you. Next we will discuss on tomorrow, next class.
Okay. Completed, madam?
Yes, sir.
Okay. Thank you, madam.
ఫోటో లేదు అంటే ఇన్ని రోజులు ఓపెన్ అయ్యారు ఈ ఫైల్ ఈ సీక్రెట్ ఇట్లా
హలో
వాడు మొత్తం
హలో సార్
ఓపెన్ అయిందా అలా మీద మీద 7 నుండి 8
హలో సార్
Yes, madam. చెప్పండి.
లైవ్ స్టాప్ చేసిల్లా
స్టాప్ చేయండి మేడం.
లైవ్ స్టాప్ అయిందా సార్
స్టాప్ అయిపోయింది మేడం.
మీరు ఆమె ఆల్రెడీ ఎండ్కి వచ్చేసింది అసైన్మెంట్ చెప్తుంది